Look up at the moon tonight. That calm silver face has watched over every human who ever lived. Every poem, every love song, every kid pointing at the sky. It feels permanent, peaceful, like it was always meant to be there. It wasn't. The moon is a scar. It's what's left over from the single most violent day in the history of our planet. And here's the part that still gets me. That catastrophe, that unimaginable act of destruction, is the reason you exist at all. To understand why, we have to go back about 4.5 billion years to a moment right after Earth was born. Back then, the young Earth was not alone. The early solar system was a crowded, chaotic place, full of half-formed worlds all shoving for the same orbit. And one of them had Earth's name on it. Scientists call it Theia, a rogue planet roughly the size of Mars, drifting on a collision course with our home. Sometime in the first 100 million years after Earth formed, Theia caught up to us. And it didn't just clip us. It slammed into the young Earth almost sideways at a speed and scale that's hard to even picture. The energy released was beyond anything you can imagine. Both worlds partially melted. A huge chunk of Earth, mixed with the shattered remains of Theia, was flung out into space, forming a glowing ring of molten debris around our wounded planet. Over time, that ring pulled itself together, cooled, and became the moon. So the moon isn't a visitor. It's a piece of us. Literally. And we can prove it. When the Apollo astronauts brought moon rocks back to Earth, scientists checked their oxygen isotopes. Think of isotopes as a chemical fingerprint. Every world in the solar system has its own unique signature. Mars rocks are clearly Martian. Asteroid fragments are clearly alien. But the moon? The moon's fingerprint is almost identical to Earth's. Not similar, practically the same. And here's what I find fascinating. That result didn't settle the debate right away, it actually made it messier. For a while, people wondered if the moon had simply been captured or spun off on its own. But an alien world and a captured rock should carry an alien signature, and this one doesn't. The only clean way to explain a fingerprint this close is that Earth and Theia melted together so completely they became one, and the moon was cast from that shared blend. That's the smoking gun. Okay, so we got a moon out of a cosmic car crash, a nice nightlight. Why does that mean life? Here's where it gets good. Our planet is spinning, and it's tilted. Right now, Earth leans over at about 23.5 degrees. That tilt is why we have seasons. Summer, winter, spring, fall. Predictable, reliable, year after year after year. And it stays that way because of the moon. The moon is heavy enough and close enough that its gravity acts like an anchor. It holds Earth's tilt steady. Over millions of years, our axis only wobbles a tiny bit, between about 22 and 24.5 degrees. That's it. A gentle, boring drift. And boring, it turns out, is exactly what life needs. Want to see what happens without that anchor? Look at our neighbor. Mars has no real moon. Just two tiny captured rocks. Barely more than glorified asteroids. Way too small to hold anything in place. So over billions of years, with nothing to steady it, Mars has been at the mercy of the other planets. The gravity of giants like Jupiter has been tugging on it, dragging its tilt all over the place. We're not talking a gentle wobble. Computer models show that Mars has swung wildly, anywhere from 10 degrees to 60 degrees. And 60 degrees is a nightmare. At that angle, the poles tip so far toward the sun that the polar ice caps can melt outright, throwing the entire planet into violent climate chaos. A world lurching between deep freeze and meltdown over and over with no stable ground to stand on. Imagine trying to build something as delicate as life on a planet like that. A climate roller coaster that never lets up. Whatever might have gotten started would get wiped out before it ever had a chance to grow into anything complex. And honestly, that's the thing we should sit with. When we go hunting for a second Earth out among the stars, we obsess over distance from the star, over water, over air. But a big steadying moon might be just as important. and it's a lot rarer than we'd like. Earth got an anchor, Mars didn't. That single difference may be the line between a living world and a dead one. And the moon did more than just hold us steady. Its gravity pulls on our oceans, creating the tides. And some scientists think those tides may have played a quiet role in the story of life itself. The idea is that the edge of the sea, where water rushes in and out, wet then dry, salty then fresh, could have been a kind of natural laboratory. A stepping stone that helped early life make the leap from the ocean toward land. There's no fossil to prove it, so it stays a hypothesis. But it's a tempting one. Now, if you think today's moon is impressive, you should have seen the original. When the moon first formed, it wasn't way out where it is now. It was terrifyingly close. Something like 24,000 kilometers away, right at the edge of where a moon can even survive without being torn apart. Compare that to today's average distance of about 384,000 kilometers. So picture the sky 4 billion years ago. The moon would have loomed overhead, covering more than 200 times the area it does today. A giant, glowing presence, filling the night. And the tides back then? Not the gentle ones we know. With the moon that close, the pull was thousands of times stronger. Every single day, the crust and the oceans heaved up and down by tens of meters. Stop and picture that for a second. The solid ground under your feet rising and falling like a chest. The whole planet flexed and rolled like it was breathing. The days were different too. That sideways punch from Theia set the early Earth spinning incredibly fast. A single day back then lasted only about 5 or 6 hours. The sun would rise and set before you finished a good night's sleep. So what slowed us down to the calm 24-hour day we have now? The moon. For billions of years, the tides have acted like a brake, gradually dragging out our spin, stretching each day longer and longer. And here's the beautiful part. The moon is still doing it. Right now, tonight, it is slowly drifting away from us at about 3.8 centimeters a year. We know this with stunning precision because the Apollo astronauts left mirrors on the lunar surface. Scientists fire lasers at them from Earth and time the return, measuring the growing distance down to the centimeter. The moon is very slowly leaving. So let's come back to that quiet silver face in the sky. It's not just a rock. It's the fossil of a catastrophe. It's a piece of our own planet, blasted into orbit on the worst day Earth ever had. And instead of ending us, it became the thing that made us possible. The anchor that steadied our seasons, the brake that calmed our days, the steady hand that gave life the millions of years of stability it needed to become something as complex as you. Earth had to be broken to become a cradle. So the next time you look up, remember, you're not looking at a peaceful nightlight. You're looking at the scar that saved us.